Hello and welcome to this instructional video on CATIA prismatic machining. We've been working on this part that you see in front of you, trying to complete the operations for the first setup. We have done facing operation, a profiling operation on the side, and a curve follow to do some engraving. So if I double click on the last operation and go to replay toolpath, and going down to the second button on the first row, click on the little triangle and go to full video. We can replay this and see exactly what's happened. So there was the facing, here's the profiling, and here is the engraving operation. So the only thing that's missing from this first setup to generate all the features that are present is a chamfering operation. So this edge here, there's a 50 thou chamfer on it. And let's go back to the CAD model so that we can see that more clearly. I'm going to hit OK here. Let's go to the front view. And if we zoom in on that edge, you can see clearly that there is that chamfer here, which is 50 thousandths deep, 50 thousandths wide. So we need to put that on the part. And the operation that we're going to use to do this is our curve follow operation. Now to do a curve follow, in this case, we don't actually have the actual corner here because the chamfer has removed it. That's one issue. The other issue is that the tool that we use for curve follow, sorry, not for a curve follow, for a chamfer, they are of course traditional special purpose chamfering tools. We are actually using a face cutter to do this. The reason being that the edges of the face cutter have a 45-degree insert angle, edge angle for the insert, and that means that we can use the facing cutter because in this case the profile that the chamfer follows is pretty open. There's no obstruction that would limit that cutter's use. Now the problem though is that we don't have a path for the center of the cutter to follow. That cutter is 2 inches in diameter, so we'd expect the center of the cutter to be out here somewhere in order to cut the edge. So we don't actually have a pad out here. We have to actually create it. So that's what we're going to do first. We're going to go ahead and create a path for the cutter to follow. And to do that, what we're going to do is we're going to jump into the part design workbench. So I'm going to expand out the first setup product and then come down here to the part itself. And I'm going to right click on the part and go down to the dot object menu and open the part in a new window. Then I'm going to maximize or fit all so that I can see the part. I'll rotate it over. And I'm going to jump into the part design workbench. And what we're going to do is we're going to create a sketch. And on that sketch, we're going to create that curve that we're going to use to curve follow. So notice here in the part I have the part body and I have a geometrical set. I'm going to right click and make the geometrical set my in-work object. So I'm going to put the geometry that I'm going to create now in this set and keep it separate from the geometry, the feature geometry that was used to build a 3D solid shape. And what we're going to do is we're just going to jump into the sketcher and I'm going to sketch on the top plane here. So select sketch. So to generate the toolpath, I'm going to want to pick this outer boundary here, or maybe the inner boundary actually, the inner boundary of the chamfer, and then offset at a certain distance. So let's go ahead and do that. I'm going to use the offset tool. So if you go under the transformation tools, here's the offset tool. And I'm going to just see what this does. I'm going to click on this face. So this here is the bottom face of the part, or the one that we're currently looking at in the setup for machining. And it looks like it did grab that outer edge, even though they are inner edges for the circles, for the holes, and the big pocket. And let's click down. And it does look like it's parameterized. So in other words, I can vary the distance by changing this value here. So let's think about how far away we want this curve to be. So we picked this edge or this face. So the edge that's being offset is the inner edge of the chamfer. And this is 50 thousandths from the outer edge. And then the diameter of the cutter is 2 inches. So the radius is 1 inch. So that's one plus 50 thousandths, or 1.05 inches. That will get us to the center of the cutter. Now, so that's 1.05. Now, we'll discuss this when we go back to the prismatic machining workbench, but we'd like that distance to be slightly larger because we want to make sure that when we bring the cutter down to do the chamfer, we're not right on the corner of the insert. So we're actually going to add a little bit extra. I'm going to add 100 thousandths. So we're going to go 1.15 offset for our tool pad. And that'll become clearer, as I said, when we go back and look at actually doing the operation. We're actually going to do that right now. So here's our tool pad. We're going to use this as the pad that we're going to follow with the curve following operation. So let's exit from the sketcher. And let's go back to our process. And there's that edge that we just created. Okay, so let's go ahead now and add in our curve following operation. Now, where do we put this in the list? Well, we have to, of course, have completed the facing operation and the profiling operation before we have an edge to chamfer. So it has to be after these two. We could do it after the engraving, or we could do it before it. We're not going to be able to save on the tool change regardless. So let's just do it afterwards. Let's go ahead and click on the curve following operation. And we're going to insert it after the engraving. For now, CATIA is going to think that it's going to use the same center drill that we use for engraving. But we're going to change that, as I said, to the 2-inch facing cutter. Let's go ahead and select our geometry. So we're going to go ahead and pick on this edge here. And now we need to pick 8 edges, 4 straight and 4 corners. We could do this by clicking on each one. The edge selection toolbar has some tools that assist us in picking loops of edges. I'll talk more about this in a dedicated video, but for now, just to show you, if you go to the second tool here, which is called Navigate on Edges until an edge, let's click on this. What this tool does is it allows you to pick the edge prior to the one that you selected. So looking at the arrow here, which is heading off in this direction, so we're going around counterclockwise. If I pick this edge here, I'm telling CATIA to try and navigate along this loop until you get back to this edge here. So let's see if this works. And it did. So now CATIA, given the direction and the first pick, it navigated around till it came back to, as the tool says, until it got to this edge. Now in this case, having 8 edges, it would not have been too hard to pick each. However, you can easily have profiles that have 20, 30, maybe even more edges, and this is really, really useful in those situations. Okay, so we've picked our edges. Let's go to our front view. And we can see that we're at the top of the part. Let's hit OK now. We have an offset in here. We may have to use this at some point in time, but for now, let's just set this to 0. We'll probably come back here and change this after we've gone ahead and generated the tool pad and seen what it does the first time. Let's go here to our tool. And as I said, we're not going to use the center drill. We're going to use the 2-inch facing cutter. So let's select the tool. So here's our tool list. Let's grab our 2-inch cutter. There we go. And so that's the tool. As you should recall, all the speeds and feeds for the tool are set. One thing to point out here, notice that on geometry, all these entities are grayed out. Previously, one could modify these. Once you've used the tool and you use it a second time, you pretty much are locked out in terms of modifying the information about the tool within the operation. You can, of course, go to the tool in the resource list and modify it there, which then means that all the operations using that tool are going to be influenced by those changes. But it's not possible within an operation to change tool parameters once you have used the tool, once you've used the tool before in an operation. Okay, so we now have our tool selected. The speeds and feeds, these are based upon the tool information. The approach and retract are copied in from the previous time we used the facing cutter, and this is fine. We'll come back to the lead-ins, lead-outs in a second. Let's go to the first tab and just quickly look at what we're going to do for our machining strategy. We're going to go one way. And as far as our machining tolerance goes, again, it's not a big issue because we don't have very many, or just the corners are circles. We don't have really any complex curves. So this is not going to be that much of a factor, if any at all. And then axially, this is our maximum depth of cut here. This would come into play if we were doing multiple passes, but with chamfering, we're just doing a single pass, so we don't even have to worry about this. So let's go ahead and generate our toolpath and see what we have. So there we go. We have the cutter approaching. Right now the lead-in, the initial approach is an axial one. So if we go ahead and rewind and then let's go to point-by-point replay. So change your replay mode from continuous to point-by-point. Let's step down. So notice that the cutter is just making contact on the edge based upon what we have set up. So we don't have the right information regarding the offset of the toolpath yet. So let's think about this a little bit. Remember when we set up the toolpath, we offset at 100 thousandths. And we know that to actually cut the chamfer, we have to go down an additional 50 thousandths because the chamfer depth is 50 thousandths. So if we want this edge to be actually in line with the chamfer, we have to actually go in and adjust the depth of the chamfer to 150 thousandths. That's that 100 thousandths extra in the offset, plus the 50 thousandths to actually cut the chamfer. So let's go ahead and do that. What we're going to do is we're going to go back to the geometry tab and we zero this off, which is what we were seeing there. Let's double click on this, and what we want to do now is change this from 0 to negative 0.15. So the cutter is going to be 150 thousandths below what we saw a second or two ago. Let's generate the two paths. Okay, so now the cutter, you can see it's actually intersecting the workpiece before it's even begun. Actually, let's rewind it. So here we are at the start. Let's see what happens when we feed it to depth. And if we zoom in, we can see that the edge of the insert is flush with the edge of the part. Now this kind of demonstrates why we did that 100,000 shift, extra shift when we did the toolpath offset. The reason was because we wanted to get away from this corner. We didn't want this corner to be anywhere near this chamfer when we are cutting it, because this is not a perfectly sharp corner, even though it looks so in the tool picture here. We want this to be shifted away. So we're actually cutting on the edge, not near a corner. So this looks good. We do, however, have an issue on the approaches and retracts that we have to deal with. So let's go to our first tab. And what we're going to do is we're going to do a circular lead-in and a circular lead-out. So right now we have some linking set. We're going to deactivate these. These were set up when we set up the engraving. And again, Katia taught that we're going to be using the same tool, but we're not. So let's deactivate this. And then for our initial approach, let's just remove this. What we're going to do is we're going to do a circular lead-in. And we're going to do an axial approach. And we're going to have the axial approach be, so this distance here is 50 thousandths. Let's set it to 100 thousandths. A little bit more, so 0.125, 25 thousandths more. This radius here, we may have to adjust this a bit since it's a larger cutter. Let's put this as 1 inch for now. We can go back and change it if it's too large or too small. And let's do the same thing on the retract. As we move the tool off the cutter, off the workpiece, sorry, let's add a circular lead out. Let's set this to 1 inch. And then in this case, we can do axial motion up to a plane. And let's pick the top of the stock, which of course is no longer there because we have faced away. So let's see what this does for us in terms of, okay. So we see the initial approach added, the circular lead-in, the axial approach, and then the retract. Now what's happening here though is that it's coming down on the wrong side of the tool pad. So the cutter is actually going to, if we did this, we'd actually bring the cutter down on the part, and we'd actually be, gouging the part because we're actually 50 thousandths below the top of the part surface. So this is not the side we wanted on. We wanted it on the opposite side. So to fix this, we have to actually flip the side of the curve of the actual tool pad that the lead-ins and lead-outs are on. So let's do that. What we're going to do is we're going to hit OK. Let's go back to our 5th tab under the approach. What I'm going to do is I'm going to double click on the arc. So the arc has two things on it. It has the angular sector and the angular orientation. So again, these question marks help to explain things. So this shows you what the angular sector means. So you can actually shorten the lead-in by changing its angle. Right now it's set to 90 degrees. The angular orientation is really the plane in which the lead-in, that circular lead-in, is located or lying in. Right now it's 0. So if we were to flip this 180 degrees, we'd actually end up mirroring or flipping the circular lead-in about the tool pad. So let's go ahead and do that. Switch it to 180. And let's leave the radius. Let's hit OK. Let's go to the retract and do the same thing. So double click on the tool pad and let's change this to 180 degrees. Let's go ahead and now replay the tool pad. And now we see that the tool pads, the lead-in tool pad, the lead-out tool pad, the circular, are now on the opposite side of where they were before. So let's see what happens. Let's rewind. So this is the repositioning of the, or the positioning from tool pad, from tool change. We're going to be going in point-by-point replay. So the tool comes down, and then it starts to work its way towards the chamfer. Let's go to our front view. So it's still on the lead-in. Okay, now it's on the part, and now it starts going ahead and cutting the actual pad. Slide through this. Let's go ahead and just do plane by plane. Let's reverse that one more time. Yeah, we won't be able to see it because it's just a single tool pad. But the tool did come back around and then worked its way offwards. So that's how you set the lead in, lead out. One can, if you want to, shorten this. It is a little bit far. If we look at the top view, we can see that the cutter is coming down quite a ways from the part. Let's go back to point by point. And you can see that it's got to work its way into the chamfer. So one could maybe reduce the angle sector here if you wanted to, or the radius to make it smaller if that's of interest. There we go. So in this video, we went through the process of creating a tool pad for chamfering. The first thing one has to have is a pad to do a curve follow. And in many cases, you might need to go into the part design workbench to actually create a sketch with that path on it. In particular, in this case, because we were using a facing cutter due to the chamfer, we had to have a path that was offset by slightly more than the radius of the cutter. So that's one thing that one has to consider, when one goes about using a curve follow for chamfering. Let's just replay the entire setup. So I'm going to go to toolpath replay, and let's go ahead to switch our mode to continuous replay of toolpath, and let's go to the second button down, the full video replay, and let's go ahead and look at what we get when we run where we run through with all the operations we programmed. So this is completely that first setup. So there's our facing, here's our edge milling or profiling, here's our engraving. And then we should see facing cutter doing the final chamfering operation. And there it is. So there are, of course, many other things that we'll get into when we get into the second setup, but this is the first setup. What we'll be doing in the second setup is flipping the part and then doing more operations. We'll be looking at pocketing operations and as well as more applications of facing and profiling. All the holds to our operations we will do during the second setup.